Welcome to the Daily MBA, where business wisdom is served fresh and fast, straight from one of the top MBA programs in the world. I'll give you summaries of my lectures and readings, as well as the most important insights gained from an MBA, so you can apply all of this knowledge in every business. Let's get started. On today's episode, I'll continue talking about options, but now we're going to talk about how to give the value to each of those options. So let's do a short review of where we left off in our last episodes. I was explaining to you the two types of options that you can get, call or put. Call, it's going to give you an option to buy, and it will give the short call an obligation to sell. On the other hand, a put position, when it's long, will give you an option to sell, and if you decide to exercise it, it will give the other side, a short put, an obligation to buy. So now that we know the relationship between these two, we can establish some important concepts, like the put-call parity. The parity is that two portfolios should always have the same future payoffs. And this is going to work in everything. I've talked about this with bonds, I've talked about this with everything, because if not, if you see something that is giving you a different payoff, there would be an arbitrage opportunity that you could take off and make some money without risk from that opportunity. So here, how are we going to do this? There were some models that were invented in order to make these portfolios similar. Because one of them you're buying, the other you're selling, you already saw the graphs look completely different. Well, technically, in this, I could prove it to you, I won't. If you want the proof, you could come to an MBA class, but now you'll just have to believe me. So the payoff of having a call and a bond is going to give you the same payoff as having a put option and a stock from that same option. So call and bond will be together, and put and stock will be together on the other side. So the price of the call plus the future value of the bond should give you the price of the put plus the price of the stock plus the value of the stock in the future. And if this condition is not true, then there would be an arbitrage opportunity and you would have to do what I explained with bonds. Get the cheap one and sell it for the expensive one. Buy cheap and sell expensive. But the thing is, how can you know the prices of each of these ones? This is going to be done through many models, but the one I'll explain today, for simplicity, it's called a binomial option pricing model. In this model, I told you it's very simple because it's only going to assume an option, a stock can go up or down. So it will only hold two pricing options for the stock. In real life, it would be stupid to believe that in 1 year, Google can either be in 300 or 100. That wouldn't make any sense. But for learning how to calculate options in a basic way, we need to take those assumptions. And so we're going to have the stock in the up state, which is the scenario where the price of the stock will go up, or we will have the stock in the down state, which will show us what would be the price if the stock went to go down. Now, let's suppose I'm going to change the company I'm using today. Let's now use General Electric. Let's say I'm going to make all of the numbers up for simplicity, that a stock today is worth $100. And then in 1 year, it can be either 125 in the upstate, it's going to be rising, it's going to be very good, or it may also fall. And in the downstate, it will be worth $80. If we know this, we can calculate put and call if we have a specific strike price, let's say, for example, of $95 here. And for this calculation of the binomial option pricing model, you'll just need 3 steps: determining payoffs, finding delta and B, and finding the price. So, sounds very simple. Let's start doing it together. First step would be finding the payoffs for all the scenarios. And so, payoffs, as you remember, what we were studying in the first episode of the options. So, for example, if I have a call in the upside, I do decide to take this call. It's going to be then my value 125, which is the future stock price, minus 95, which is my strike price. Then this is going to be $30. I would get as a value on the call on the upside. This would be my payoff. Then, on the downside, because the stock is lower than my strike price, I wouldn't even take the option to buy it. It would be full of me. So, I wouldn't take the option. My payoff would be 0. If we did something similar for the put, you could also calculate the other way around. So put on the upside, it's always going to be 0, and then put on the downside, which is where you make a little bit of profit from it, would be the 95 that you're selling it for minus the 80, so $15. You always have to calculate it this way, and this is a hack that I found. If you are calculating payoffs, you can always put call on the upside, call on the downside, put on the upside, put on the downside. Always the 2 in the middle should be 0 because you don't want to take that option. It's not going to give you any payoff since you'd be losing money. So this is an easy way to find it, but here I'm going to simplify it even more. Let's put all the puts aside right now. I'm only going to focus in the call. This is a process that we could replicate with the put, but while I'm explaining it to you, I'll only use call, so it's more simple. So I have call on the upside, it will give me $30. Call on the downside, it will give me 0. And so what do I do next? I'm going to create a hypothetical portfolio that's going to include delta and B, and it's going to give me the same payoff. So we already know the payoffs, 30 and 0. Now, what are we going to need? A portfolio with delta shares. Delta is just going to be an amount of shares, but instead of saying X shares, we'll say delta shares. And then B, bond strips. So we're going to include both shares and bond strips. Why? Because basically it's the only thing that we know so far the price of. So we're going to take those two. And we're going to create 2 portfolios because we need to replicate these 2 payoffs. So one payoff, it's going to be for the upside. So here I'll have a delta amount of shares that I'll be buying for 125 plus a B amount of bonds that I'll be buying for 100. Let's say it will give me 100 in the face value. That should give me $30, right? Because 30 was my first payoff. And now, if we go to the second one, then I would get delta multiplied by 80 because now it's going to be the stock on the downside, and then plus also same amount of bonds, so B times 100 equals 0. And this is probably going to take you back to high school. You have 2 different variables, 2 different equations. What do? You have to cancel one of them out. But the good thing is that the bonds here are going to be the same because we're using same face value, 100. So I can just subtract my second equation from the first one, and that would give me that delta multiplied by 45, which is the difference, 125 minus 80. That would be difference upside and downside. It's going to give me 30. And 30 is the difference between what? 30 on upside payoff and then 0 downside payoff. 30 minus 0, 30. And from then, we can just get our number for delta and our number for B. So what does the delta mean and what does the B mean? I'm going to talk about that at the end of today's episode. But for now, you would only have to know you already found them. So that's very easy. Now, plug them in and find the present value of the replicating portfolio. So for doing that, we're going to use the stock price for today. So remember the 100, now we're no longer going to use upstate or downstate. This one's going to be stock price today and we're going to discount the bond, bring it to its present value using the risk-free rate that's available for bonds. So if we did all of this math, and don't worry if you're feeling kind of lost, I'm sharing all of this that I'm doing on the video, we would get that the amount is 14.89. And what would this mean? That the price of the call today should be the same as the price of the replicating portfolio. And so therefore, price of the call must be $14.89. See, that's how easy it would be. The thing is, delta will tell us how much effect will a stock price have if something changes in the values. So let's say the stock is now going to rise $1. How is that going to affect my payoff? It's going to affect it by 1 delta specifically. So for calls, you'll always have a positive delta, and for puts, you'll always have a negative delta. This is also a way to check your process. If you got a negative delta for calls, you're wrong. You should always get positive delta for calls. And so if the stock price today goes up by $1, then the call will go up by a delta amount, so whatever your delta is, and your put will go down by whichever its delta is. And this is going to give us important relationships, because if stock price rises, I already told you what would happen. The call would go up, the put would go down. What if the strike price rises? Then it would be the opposite. The call would go down and the put would go up. And lastly, what if volatility rises? What if I am with a stock that's constantly changing its price? Then this would make both go up, call and put. Why is that? Because you're incrementing your possibility of potentially getting the call or potentially getting the pull. Since the stock, it's just going up and down, up and down. And so both the call and the put are going to get the possibility of doing this. And so this also reminds me of important concepts that we have to define, and it's how do we bet on volatility. So a bet on volatility could be when you buy both a call and a put, because you may be betting on the stock to go whichever direction. The opposite would be true if you bet on neutrality. So here, you would sell both a call and a put because you don't believe these stocks are going to have too much movement. So if they are too volatile, you want to buy both. And then if it's neutral, you want to sell both of them. Okay, and now, for concluding, I want to talk a little bit of how real this model is. Because I just told you we would have two options, a stock in the upside, a stock in the downstate. Stock in the upstate, and stock in the downstate. So, how are we going to determine if this model is true or real? It's not. And it's not the one that's actually being used. The one that's being used, it's called the Black Scholes Model. And this model is going to follow same logic. So it's very important that you understand this one, but it's going to replicate to infinity. So let's say today I already have option up, down, but then tomorrow my down can go down again or up, and then my up can go up and down, and it starts opening like little branches that are going to be moving around up to infinity. And this model has a horrible equation that I can share in the comments. And it's also very hard to elaborate on. The thing is, also, you already have the prices set up for you. And options are something harder to value than stocks or bonds just because they feel so much more like you're betting on something. It doesn't feel like investing. You're not holding something that you're going to have for long term, but you're just betting on the stock to either fall or to rise. So this is going to be all that I'm going to explain about options. If you want to learn more about the Black Scholes model, I would recommend looking for it somewhere else and trying to understand that horrible equation where you'll just have to plug in the numbers to make this model that I just said a bit more harder and complicated. But I hope now you know how to value options, stocks, and bonds, and that you know how to better take your investment and financial decisions.